Good afternoon, everyone. We are back with the third session of the day. With us today, we are having a very renowned resource person from Guwahati University. She is Paramita Roy, Assistant Professor in Department of Statistics, Guwahati University. She did her graduation with Statistics major from Cotton College and was the best science graduate from Guwahati University. She again topped post-graduation in Statistics from Guwahati University. Ms. Paramita Roy started her career in actuarial consulting industry in Patni Computers Private Limited, Noida, followed by Mercer India Private Limited, Gurgaon. She cleared a number of papers from Institute and Faculty of Actuaries, UK, and Institute of Actuaries of India, Mumbai. Presently, she is Assistant Professor in the Department of Statistics, Guwahati University. Her skills include unit-level data extraction and data analysis using SPSS. Today, her topic of deliberation will be data selection, cross-tabulation, test of association or independence. Welcome, madam, to this FDP. I welcome you to the Department of Business Administration, and the session is all yours. Thank you, ma'am.
Thank you, Dr. Chaudhary, for your very kind introduction. A very good afternoon to Dr. Chaudhary and the other organizers and to all the participants in this FDP. So without further ado, I think I will start sharing the screen, Dr. Chaudhary, if that's okay.
Sorry to interrupt you, ma'am. Actually,
Yes.
your bandwidth is so low. So
Okay.
if it is possible, please switch off your camera so it is like whenever you share your screen,
yes.
is visible to us. Okay.
Yes.
Thank you
yes.
so much, ma'am. Thank you so much.
Yes, I think I'll shift the device as well to a device with a better net connectivity. So I request you to just give me 5 to 10 seconds for that. Thank
Sure,
you.
ma'am. Sure, ma'am.
Yes, thank you.
Yes, so I hope I'm audible. Hello, am I audible?
Yes, madam.
Yes.
Yes, ma'am.
So let us get going. I shall be sharing my screen presently. I hope you all have got access to the data that I had shared. So if we all could work together, then I guess we will sort of progress quicker. So I have opened the data. I want to give you a small glimpse of what the data actually consists of, and then move step by step, starting with data selection. So today, in the first few sessions, I'm sure you all have been made familiar with things such as the types of variables and labeling, and as well as putting the values, etc. So my data primarily, if you go to the data view part, you will see it appears like, it's all digits and this and that. So sector 1, state codes are there. Then there are district codes, there are genders, but then none of them have apparently any, proper values per se. So the way I have coded here, the coding is visible under the values section. So if you go to sector, I have coded this as 1 for rural, 2 for urban, right? For the state coding, I've taken the northeastern states and included Sikkim there. And you see, this is my coding. So if we are dealing with data pertaining to Assam, we would be coding it as 18. We'd be referring to that as 18 because my data reflects that, right? So similarly for gender, I've coded 1 as male, 2 as female. Marital status, I've coded in this way, 1, 2, 3, 4. So as you can see, a lot of my data is nominal in nature, with the exception of the last 2 which are education level and standard of living, which are ordinal in nature. And in between, there are a couple which are scale variables, right? So since we will be proceeding to do tests of association, that is the precise reason I have tried to select data in this manner. Now, I hope the rest of the value labels would be self-explanatory, because as you can see, there are different levels of each data. Just like I have got 8 states under state code, so there are 8 levels to the nominal variable. Similarly, for gender, there are 2 levels, males and females. Marital status has 4 levels. Social groups again it has 4 levels, coded 1, 2, 3, and 9, so on and so forth. This is basically an extracted data set pertaining to the employment situation in India. So this is actually a live data, but then I have made it smaller to enable proper analysis within the stipulated time today, right? So these are my variables. So whenever you see 1 under gender, you are to understand that is male, because that is how I have coded the data. I hope this has been explained in the previous 2 sessions. Another way for you to look at the data in the data view itself is by clicking this icon. So once you have clicked on this icon, whatever we have coded in the labels will come out here itself. So sector, wherever there was 1, it will show you rural. State codes, wherever there's Assam, that means that is 18. Male is 1. So on and so forth. Employment status, employed is 1, unemployed is 0, etc., etc. So this is another option wherein, for your own benefit, you can view it as you like. If you want to view it as the data is present, so then again, if we click here, the original raw form of the data is available to you. And once you again click this, then you see, again, we revert to the values, right? So I will be keeping the data in the raw form, because usually in social sciences, this particular data set is from NSSO. So they publish PLFS data for regarding employment, unemployment situation in the country. This has been extracted from there. So when you're working with live data, your data is going to look like this. And you will get attached schedules which will clarify to you what label is to be assigned to what. So the labels that I have assigned here are on the basis of whatever NSSO has prescribed with respect to this data, right? So this is how we arrive at a live data set, and then we work with it. So if this part is all right, I shall proceed with the first topic entrusted to me, which was data selection. Now, as you can see, we have data pertaining to various genders, various sectors, rural, urban, various states of the Northeast, right? Various social groups, various religions, etc., etc., various education levels. So what happens is, suppose you are interested in performing your research only with respect to, say, the state of Assam. Okay, so in that case, we will want to analyze data only pertaining to the state of Assam. So your entire data set will not be required in such a case. So what we would do is, we will go to our variable view, and then under states, we see that we have got data on 8 states. However, my research, suppose, is pertaining to only the state of Assam. So what I would do is, I would require only the state with the code 18. In such cases, data selection comes in very handy, because it is hardly the case that we analyze all the rows and all the columns of the data available to us. We need to pick out a few which are of interest to us and then analyze. So in our case, we will select Assam. So what the way I would approach the session is, first question, let us do impromptu, and then we will, go one by one. So say we need to know what is the average income of the people of Assam, given in our data, right? What will we do in that case? We will simply go to data. Under data, I hope this is visible. Under the data, this is the fourth from left option that you have, data. Under data, we have something called select cases. Now, the default option for select cases is all cases. That is why when you are seeing the data, you are seeing all the cases here, whatever is the number of the cases that you have, which is, say, 391 in my case. So you are seeing all of this data. And if you do not select cases, you would be analyzing the whole of the data. However, we are interested in Assam. And we have already checked with our data that the state code for Assam is 18. So we will have to insert an if condition in this case. What is the condition? If what? If state code, you have got two ways to sort of bring it. Either you click on state code, push the arrow and bring it to the right, or what I usually end up doing is I simply double click this. So it comes to the right. Okay. So for me, I require data only for state code 18. Okay. So I have typed from here. You are free to type from the keyboard as well. So state code 18 refers to Assam in this case, right? So I will click on continue. Okay. And then we are done with the upper section of selection. Now we come to the output section of selection. What do you want to do with those cases which belong to Assam? Do you want to filter out the unselected cases? That is, do you want to filter out the cases pertaining to Sikkim, Arunachal, Tripura, Mizoram, Manipur, Nagaland, etc., etc.? Right, and then analyze only Assam. Right, so this is the most commonly used option, filter out unselected cases. What it does is, it will, if you click OK, you see an output window comes out. In the output window, you can easily read the code that you have given. So you have filtered on the variable state code, and you're interested in only state code equal to 18, right? Now, going back to my data set, you see, wherever the state code is not 18, all those cases have been cancelled out on the left. Can you see, except row number 7, where state code is 18, and row number 16, and below also there'll be a few rows, all the rest have been filtered out. That means now whatever kind of analytical steps you want to take, that would occur only in case of Assam, because they are the selected ones and the unselected ones have been filtered out. So this is what happens if you filter out data. What is our other option? Let us try that. So if state is equal to 18, the second option is copy selected cases to a new data set. So if you want to keep this data set as it is, right? And if you want to simply take out the cases pertaining to Assam and put them in a new data set, then you would be selecting this option. So in this case, you can give any name to the data set, say Assam. Okay, and let us then press OK and see what happens. So what will happen is, yes, I think if I share my screen, then yeah. So what would happen is, you see, you end up with a new data set, which is given as Untitled 2 within bracket Assam. I had named it as Assam, right? I hope this screen is visible. So in such a case, yes, in such a case, you have copied, you have taken out the cases pertaining to Assam into a new data set And this file will only contain cases of Assam. As you can see, the state code for all cases here is 18. So you have got 99 cases which belong to Assam, right? So now you are free to analyze whatever you want to analyze pertaining to Assam from this data. So this is our second option. So if this is clear, I'll close up this data set. Right. So now I will try and move into the third option. So look, what is going to happen in the third option? As is obvious from the option provided here, delete unselected cases. So since under selection, you have selected Assam, so all the data pertaining to the states which are not Assam will get deleted, and you will be left with only data pertaining to Assam in the same file, mind you. So in case you are using this final option, you have to be very, very careful that you have saved your original data set and then you have done the deletion. Otherwise, by mistake, what often happens is, see, if I select this option, right, and I click OK, now what is going to happen, see, from my original FDP data set, all the other states have vanished. So I cannot tell you regarding any analysis I want to perform on Meghalay or anything, right? So it is always better either to filter out the variables, which is the first option, or to copy it to the new data set than fiddling with the original data set, because coding takes time, right? So if you delete your unselected cases and forget to save the main file and end up saving this, you would have lost all your data on the other sets. So the third option ideally should be used sparingly for our own code, right? So what I'll do is I'll not save this. So no, I do not want to save this, because if I save this, then what I will do is I will end up sort of losing out data on Meghalay and other states which I want to share with all of you, right? So I will try and again open up my data set. Please give me 2 minutes of time. In the meanwhile, are the options clear? If there are any questions regarding this. Yes, you can definitely select select more than one state at a time. I will show that to you as we move on. So multiple selections and all this, I will definitely be addressing. But primarily, I wanted to share with you how the data selection screen looks like and the options provided, right? And after this, we'll be moving on to exercises where you will see what happens in multiple selection. So we have seen what is all cases. That means your original data set is maintained. If is, if you want to select a particular state, or if you want to select a particular gender, or if you want to select particular income, education level, one at a time, all at a time, in that case, you use the if condition. Now, our third option, which I have used for this data, because my original data set had more than 5 lakh cases. So from there, I brought out this small data set for all of you today using this thing. First I used the if condition for northeastern states, and then I took a random sample of cases. Now this would be useful, if you are shortening your data set and you do not have any specific condition in your mind. Say you have 5 lakh data, however, due to time or other constraints, you require only 500 cases of your data. In that case, what will you do? You will click on random sample of cases and say if you have 5 lakh from there, 500, 5,000, 50,000, whatever it is. If you want 50,000 cases, you will put in here as 10% of all the cases. So let me see, I have 391 cases. So if I type out 10% of all the cases, I should end up with around 39 cases. So what I'll try and do is I will copy to a new data set so that, we do not lose out on time on opening this data set again. So I'll name it as random sample. So here my original file contains 391 cases, but I want to select 10% of that. So I have copied it to a new data set. I'll press OK. Okay, random sample is not valid because there's a space. I'm sorry. Yes. So, okay. SPSS is very sort of sensitive to how you name things. So you have to be a little careful with that. So as you can see, this is my new data set. It has approximately 10%, around 50 cases, you know, it has given me. So this is another way of sort of, if you do not have a particular condition in mind, but you want to have a smaller database, in that case, from the original huge data file, you're free to select any percentage of cases that you want. Okay, so it is approximately, it has not given me 39 cases, but it has given me 50 cases. So yes, right. So I'll be closing up the new data set. So this was the second condition under select cases. And the third one is based on time or case range. So see, if you have 5 lakh data and you want only the middle, say, observations from say 1 lakh to 2 lakh. So what you will do, you will type here your first case to be 1 lakh observation, and your last case to be 2 lakh observation. So, and then continue. So you will have those middle cases only, you know. So in my case, I've got 391 cases. Say I want my cases from, I'm sorry, from case number 51, say, to case number 100. I'm only interested in analyzing the cases that lie in that range, you know, that this case is nothing but that number of row that you're referring to here. So say from my 51st row to my 100th row I need. So let me copy this to a new data set again. Let me name it as random sample. If I click OK, then what would happen is you would end up with, see, from 51st to the 100 cases open, all the rest have been filtered out, right? So now whatever analysis it is you want to perform, that analysis will be performed only from the 51st to the 100th case only, the rest have been filtered out. The last option that is present here is not that important. It is the same as using the if condition, because once your if condition becomes effective, then a filter variable is created. We will see how that happens, and you can use that also. So the use filter variable option, I'm skipping here because it is always better to use the if option. Last but not the least, before we go into the exercises, see, one thing is important. You need to see the boxes which are checked. You know, once you start analyzing again, right, tonight you did your research on Assam, etc., you saved your data set, you know, you're back tomorrow, you want to analyze the whole of Northeast India, you know, you should be aware that you again need to go to the selection box and select all cases, you know, which is the default option, and then press OK. Otherwise, what is going to happen is the next day you are going to get results only on Assam. You know, it has happened to me a lot of times, and then I'm like, okay, why is it happening? Why is it happening? But these are common sort of things we tend to ignore usually, right? So whenever you're done with data selection and you want your entire data set to be active, please undo all the rest and select all cases, and then, you know, you can proceed, right? So now let us try and do some exercises on data selection. As you can see, I have a few questions here which we will try and solve together. Till here, are there any questions? Yes, it's clear. Okay, does it randomize? No, it's simply, it's an internal program of the SPSS, you know, it just selects randomly, right? No, it will be biased. It will not select data from all the states equally. I mean, that is sort of too much to ask, because look, the criteria on which SPSS would select, it cannot actually think like we are thinking, right? So we are thinking that we want data to be equally spread across all states. However, if you look at my data file, there are around 15 variables. So SPSS would not choose state, as a particular variable on which it will randomize. It will simply randomize your data, because you see, why not on social group then? Or why not on household size? Or why not on standard of living, right? So if you want, state-wise equal entry and all, those will not come under your randomization tag or under your random sample tag, right? So I hope that answers your question. Okay. So shall we proceed to the exercises and work out things now slowly? Okay. Okay. Right. So the first, we have to consider the data given on employment pertaining to Northeast India. Okay. So find the number of graduates, okay, in Northeast India present in the data. So you see, the first thing that should strike us is we are referring to Northeast India, right? So you need to use the entire data, but you have to make a selection based on what? Based on the education level variable, which I have given here. So that should be obvious to you when you have coded also, right? Just because this data set is new to you, that is why I have given the education level also. So you see, you can find out graduates from education level. If I click on the value, you see 6 pertains to the graduate level. So, we have been asked to find out how many graduates are there from the entire data. So graduation or education level is the variable on the basis of which we select. So we will go to data, select cases. If education level equals 6, because that is graduate and we want data on that only, right? So continue, right? And I will be simply filtering out unselected cases. This is the most convenient option to use for your output. Okay, so I'm filtering out unselected cases. So, okay. So in your output file, you can see, we're filtered on education level 6. So now if we want to find out the number of graduates, so, oh wait, I'm sorry. Yes. So coming back to data view, you can see that education level 6 is occurring in this row. So this has been selected. The rest are unselected. Again, in this row, in the 6th row, there is education level 6. So this is selected. The rest are unselected. So whatever statistics we find now using any of the options, using analyze or whatever you want to use, that will only take data for education level 6, the ones which are open, the ones which are not crossed out. The crossed out ones will be left out from our analysis. Okay, that is what we want. So we wanted graduates, we selected graduates. Now let us simply see the frequency of education level. Okay, so if we click OK, you have got 33. Now, mind you, this is the number of graduates only, 33. It is not giving you the total number of people present in the data, because that would be 391, as you have seen in the data. It is only giving us the number of graduates because we have selected education level 6. So the analysis that you're performing on education level will only now be based on education level 6, as you can see in your coding here. So is that clear? So from our data, we see that there are 33 graduates in Northeast India present in the data. Is that okay? There is another way to check whether this data, whether this output is correct or not. Let us now unselect all cases. So let us, analyze all cases. In that case, again, if you go to analyze, descriptive statistics, frequencies, push your education level here because we're interested in the education level. Click on display frequency tables, click OK. What do you see? Herein, you get the entire picture of your education level, the distribution of your education level, because we have not selected any data, right? And can you match this 33 that we had when we had selected education level 6 as graduates? So there are 33 graduates. Can you check here? Graduates number is 33. So our data selection procedure is correct, right? The second thing that I have shown you is without any data selection. So without selecting any data, if you analyze the whole data, you have got 391 cases. And this gives you the total distribution of those 391 cases. However, if we are only interested in graduates, say, or postgraduates, then we would make a data selection and you would end up with such kind of a result. So is the first question clear to everyone? How we have arrived at the result? So if you want to check the average income of all graduates of Northeast India, say your question is, find out the average income of all graduates of Northeast India, what you would do is select cases if, we already had education level equal to 6 here. Let me again push it this way. Education level equal to 6. Continue. Okay. Now, we will go to analyze. Just a second. Something in the chat box. Yes, it's clear. Okay. So, yes, analyze, descriptive statistics, descriptives. So we want the average income, mind you. So under descriptives, we will push the income variable on this side, go to options, and we only need the mean, average, right? So we have selected the average option, continue, okay. So as you can see, the average income of graduates in Northeast India, there are 33 of them, N is 33, right? So for those 33 graduates, the average income is 15,309 rupees 9 paise, right? So this is how we proceed with the analysis. We are sticking to one variable. So now let us go to question number 2. Find the number of graduates and above in Assam present in the data. So as you can see, now there are 3 things involved here. First is you need graduates and above. So you need postgraduates also, right, in your data. So you need education level 6 as well as 7. And where should they be present? They should be present only in Assam. So we are now interested in analyzing how many graduates are there, how many people are there in Assam who are graduates or above, right? In such a case, this is the case of multiple data selection. What we will do is data select cases if. So let me push this variable to the left. First thing is we need our state. So for state, Assam is 18, as I've already told you. So state code 18 and education level, sorry, I haven't pushed it. Education level is equal to 6 and education level. Okay, first let me do with education level 6 only. Let me first do only for graduates. So we want to see how many graduates are there in Assam. So education level 6, state code 18. We are using the AND operator here because you need both these conditions to be satisfied, right? We need the number of Assamese graduates. So you will need them to belong to Assam as well as you will need them to be graduates. That is why we are using the AND operator that is present here, right? That is what I've pushed in, the one here. So continue, filter out unselected cases. So as you can see, all the non-graduates have been struck out. Also, all the non-Assamese people have been struck out. So only graduate Assamese people have not been struck out here. So what do we do now in such a case? I'll get back to your question a little later. So we'll again go to analyze descriptive frequency. We are trying to find out the frequency, right, of graduates of Assam. So again, education level. Okay. So you see in the data of 391 people, you have got 5 people who are graduates. Okay, in Assam. So from the coding also you'll be able to infer. So we have found out the number of graduates who are there in Assam. So now I'll get back to you. After creating a new variable, will we change its scale? That is the question. I could not quite get you. Can you please be a little more elaborate? Missing. So yes. Right. So in the meanwhile, let me proceed. Now let me see graduate and above. There are 2 ways to do this. Okay. If we want to find out the number of people, with education level graduates and above, what you can do is, first of all, let me here select all cases before I further code the data. As you can see in the variable view, education level 5 is for graduate, 6 is for graduates, 7 is for postgraduate and above. So ideally we require education level 6 and education level 7 for my second question. So one way to approach it would be, as you, I guess in the previous class, all of you had done, transform, recode into different variables. So we are trying to put education level 6 and 7 together and then select those cases. So in such a case, we will recode into a different variable. Our input variable would be education level because that is what we are trying to decode. Say our new variable's name is education 1. Let me change it. Old and new values. See, what do we want? We want 6 and 7 to be the same value. So either you code it as 6 only or as 7 only. So our previous value 6, if it is, we'll code it as 6 only. If it is 7, then also let us code it as 6 because we want 6 and 7 together. And for all other values, we'll copy our old values, okay? Because 1, 2, 3, 4, 5, we are not fiddling with it. We are keeping it as it is. We need graduate and postgraduate. So graduate also is 6, postgraduate is also 6. We have coded it in that way. And then let us continue and press OK. So what we have done is we have created a new variable with, 6 and 7 clubbed together. So what you can do is you can simply copy Control-C this and Control-V in values. Everything has the same meaning except you remove 7 because now 7 no longer exists. We have coded 7 as 6 only because we have coded it as graduate and above. So I will change the name. So this part, since it was covered in the previous session, so I'm not covering the coding in detail, but this is one approach how to do it. Okay, so okay. So now we can work with our new variable education 1 and see how many graduates as well as postgraduates are there in Assam. Let us do that. Data, select cases. If state code is 18, and now we will use our new education variable education 1 equal to 6 because now in this new variable 6 represents both graduates as well as postgraduates. So let us continue. Okay. So now if we revert to the data, all the non-Assamese people have been struck out. Also, all the people having education level below graduation have been struck out. So only graduates and above remain. So now if you press analyze, descriptive, frequencies, and then education 1, you will get the answer as 7. So in Assam, the number of graduates were 5, but the number of people who are graduates and above, that means graduates or postgraduates and above, are 7. So there has been an addition of 2. So 5 graduates and 2 are postgraduate and above in Assam. Now let me go to the chat box. Yes. I was coming to this. Niladri, I'm so sorry. I will go slow just because it was recording. That is why I went a little bit fast. In selection thing, I will go slow. And Mr. Tapas Kumar Sahu, you're absolutely correct. We can definitely use greater than equal to 6 command. I was coming to that. So there are various ways to approach a problem. This is one way. You can compute a new variable and approach, or you can simply go to data, select cases, and as Mr. Sahu has very correctly pointed out, from our original variable only, see, state code is 18, so you have got people from Assam, and your original Purana variable, which is education level, 6 and 7 represented graduates and above, so greater than equal to 6. This will also work absolutely fine. So let us try and do this way also. So I've selected this, and now analyze descriptive frequencies. Now we have to bring back our education level, because again, now we are working with education level, not education 1. See, you get the same result, 7. So there are various ways in which you can approach the same problem. The first one was recoding. The second one, we did not record. We simply wrote greater than equal to 6. Because once you have written greater than equal to 6, you are including all the data, which is 6 or above. So 6 or above is 6 and 7, and that is exactly what we require, right? So I hope this second question is also clear. Now, let us go to question number 3. Compute the average income for people in Assam. Right, so I have kept it Assam. You're free to do with any state that you please. And I'll later on show you how with a single command you can get the same result for all the states also. But we'll come to that at the end. For now, let us compute the average income for all the people in Assam. Again, we will go to data because we have to select only the Assamese people. So we need state code 18. So if we do not need anything pertaining to education presently, you can simply select that and press delete on your computer. So press continue. Yes, I'm sorry. I could not unmute myself. Thank you very much, Dr. Yes. So we were in question number 3. So we were trying to filter out only, we were trying to only find out the cases pertaining to Assam. So my selection criteria was state code equal to 80. So I've pressed continue here. Okay. So now in my data, I am left with only people from Assam which are not struck out, right? So easy now. You go to analyze, descriptive, again descriptives. Even frequencies gives you the option. So you can choose anywhere to find out the average. Let me go from descriptives only. So income variable, let me bring it on the right. Options, mean, continue. Okay. So as you can see in our output, we have got 99 people from Assam whose average income is 8,826 rupees 54 paise. Right? So if you're asked from a huge data set that what is the average income of people from any state, you should be able to find that out. Right? Now, if this part is clear, we will proceed to question number 4. Find the number of people in Assam whose income is less than 10,000 rupees. Okay. So we are now selecting on 2 criteria. First of all, you need people from Assam. So you use the state code criteria. The next criteria you use is income, right? So let us go to again data, select cases. If state code 18 is present here, if it is not present, we will try and bring it from the left. And income is less than or less than equal to was the question, less than. So as you can see here, you have got option for strictly less than or less than equal to. We will use the less than option because that is what our question asks us to do. Less than 10,000, right? So we click on continue, filter out the unselected cases. Okay. So now if we go back to our data, so all the cases where even people from Assam whose income is greater than 10,000 have been filtered out. As you can see, our case number 16 is filtered out, even though it is from Assam. Why? Because his or her income is 10,500 rupees. So, only the cases where people are both from Assam as well as their incomes are less than 10,000 rupees, they have been included presently and not struck out. So number of people we require. So definitely we will go to frequencies again, with respect to income. So fine. So there are 70 people out, there are 70 people out of a total of 99 in Assam whose income is less than 10,000 rupees. Right. Because in the previous case, we saw the mean income of Assamese people was 8,800. See, this is also to be expected, right? Because out of a total of 99 people, if 70 people's income is less than 10,000, the mean will definitely be less than 10,000. So our mean is 8,800. So these are small sort of cross references you can build up in your head. Yes. Neha, can you please tell me which part you want me to repeat? Yes, by the time you can type it out, I will then proceed to the next question. Oh, you got the results. Okay, thank you. Excellent. So let us move on to our 5th question. Now, let us get into a little bit more of the data. So now let us see, find the number of people who are employed in rural Assam. So you need to understand that now 3 variables would be involved. One is your employment status, whether people are employed or unemployed. Second is your sector, rural or urban. Third is your state, Assam and non-Assam, right? So we will have 3 conditions, right? So you need employed people from rural Assam. So I have already given here your sector code rural is 1. You can see that from the data itself. First of all, let me unselect all the cases. This is very important. You need to select all cases and then proceed again. So from your variable view, it should be clear to you. See, in your coding, you should put sector equal to 1 because we want rural. We need Assam. So state equal to 18. And we need what? Your employment status Oh, I'm sorry. In the question, I've put it as 1 and 2. It should be 0 as unemployed and 1 as employed. Let me make the correction. So 1 is, yes, 0 is unemployed, 1 is employed. Okay. So we have 3 conditions. Sector 1, state 18 and employment status 1. Okay. Now let us try and do that. So data, select cases. If, let me throw this out. Now state code equals 18. So we need people from Assam, right? And you need rural people from Assam. So sector equals 1 because 1 stands for rural. And you need them to be employed. So you need employment status as 1 because 1 employment status refers to as employed people. So this is our condition, right? Continue. Okay. So now if you look at your data, see all the people who are not from rural Assam and who are unemployed have been struck out. See, 53 is not struck out. Why? Because see, it is Assam. So it satisfies this criteria. It is rural, 1 satisfies this criteria. And where is its employment status? 1. That means he or she is employed. So all 3 are satisfied. So case number 53 is not struck out. However, case number 52 has been struck out. Why? Because even though this refers to, rural Assam, however, you see employment status is 0. That means he or she is unemployed. We do not need him or her in the data. That is why he or she has been struck out. Okay. Now we need number of such people. So, descriptive statistics, frequencies, employment status, let us see. Okay. So there are 27 such people. So you can say that 27 people of rural Assam are employed. Is this part clear? How do we deselect the data? Yes, good question. What you do is you simply go to data, select cases and click on all cases and click on OK. So that will remove all your filters. As you can see in your output box, you will get something written as filter off, use all. So all your filters are off. You have not filtered out any data, use all. So you're using all data that has been executed. So I hope I have answered your question. Yes. Dr. Gupta. Yes. Yes. So is this part clear? Right. So let us move to question number 6. So find the distribution of people by employment status in Assam. So see, this is a very easy question actually. What, let me see. Okay, please repeat this. Dr. Vijay Kumar says, okay. Harshitha Solanki, 5. What do you want me to repeat? Question number 5? Sure. So in question number 5, we have 3 conditions per se, because you want to find out employed people, you want to find out people from rural Assam, from rural areas, and you want to find out people from Assam. So these 3 different things will have 3 different codes, right? So I'm sorry. Yes. So for doing that, we will go to data selection. So you will need to select 3 kinds of things. What is your first kind of thing? You want people from Assam. So state code 18. Next, you want people from rural areas. So sector 1. So now you have people from rural Assam. And you want people who are employed. So employment status 1. So these 3 conditions satisfy the people who satisfy these 3 conditions at the same time. We want these people only. So continue. Okay. So now our filter is not off because as you can see, compute filter. So our data is filtered now. It does not have all the data. Now, if you go to analyze, descriptive, frequencies and push your employment status on this side and click an OK, you will get your statistics that there are 27 such people who are employed in rural Assam. So out of the total population of Assam, here it is 99, not population exactly. Our sample constitutes of 99 Assamese people. Out of them, 27 are such who are from rural Assam and who are employed. Okay. Okay. Thanks, Arshita. Okay. Now, let us move on to our next exercise. Okay, so we want to find the distribution of people by employment status in Assam. So distribution is nothing but, you want to see how many people are employed, how many people are not employed in Assam. So you need to remember, we will not select anything on employment status because you want to see both. When you refer to the word distribution, it means you want to check out the entire pattern of the data. So if you're checking out the entire pattern of the employment status, that should include both employed as well as unemployed people, right? So we will not touch employment status in our select variables, but we will touch only Assam because we want the distribution only for Assam, right? So let us proceed. So we will go to data, select cases, if only Assam. Okay, so we need only the people from Assam. So continue. Okay. So now for your analysis, analyze frequencies, display frequency tables with respect to employment status, because mind you, our question was you required the distribution of employment status. So when we are finding out the frequency distribution, we will find out with respect to the employment status variable, right? And just click on display frequency tables. What it will do is it will show you the frequency of the people who are employed as well as unemployed. So as you can see, there are total 99 people in Assam. This result we had got in the mean also, right? When we had solved the question on the average income. So there are 99 people in Assam. Out of them, 64 are unemployed, 35 are employed. Okay. Right? Right. Okay. So this is pretty easy. So you can find out different kinds of distributions with different kinds of selection criteria. Now let us go to the next question. Number 7, find the number of women. So mind you, we are now referring to women only. So there is a selection criteria there. On what? Based on what? Based on gender. So number 1 variable would be gender. So we would select cases based on gender. Next, aged between 25 and 50, right? So another selection criteria is what? Your age should be between 25 and 50. Okay. So we have got now 2 selection criteria. One is gender, one is age. Who are employed in Assam? So third criteria is employment status. So you need only people who are employed. So we will code it as employment status 1. Okay. And 4th is in Assam. So state code should be 18. So we are slowly moving towards, clubbing 3-4 criteria together, as someone had asked in the beginning. So now we have 4 criteria, mind you. So we will go step by step. Right. So data, select cases. If. So see, state code 18 is present here already. So I'm not pushing it. Otherwise, you would have had to push it to the right, right? So state code is there. Next, we need gender. Remember, we were only dealing with women. So women are what? I mean, I've given in the question, or I should. No, gender I have not given in the question. So what all of you need to do is go to, let me cancel this, go to variable view and check out what is the coding for women. It is 2. Okay, so let us select cases if state code 18 and women, so gender equal to 2 and age greater than equal to 25 and age less than equal to 50. So now we have 3, but I was saying there are 4 criteria. We need employed also. So and employment status 1. So what we have done with this criteria is we have selected people from Assam, state code 18. We have selected women from Assam because gender 2. We have selected women from Assam aged between 25 and 50, the third coding, and we have selected women from Assam aged between 25 and 50 who are employed with the fourth condition. That is what we were asked to find out. So continue. Okay, right? So we need to find the number of such people. So yes, again, analyze frequencies. You can put on employment status also. There is no need to display frequency because we have got a lot of select conditions. So we are not finding out the distribution of anything. We are simply finding out the number, a single number. So you can omit this display frequency tables because it's not going to work correctly in this case and it will not be of any use. So you see there are only 2 such people. So there are only 2 women in Assam aged between 25 and 50 who are employed. The rest are all unemployed. Yes, it is 2. Harshita and Neha. Yes. So your coding also you can see on top in your output file. So there are 4 kinds of codes. You know, if you're confused with the question, you can always go back and check with that code also what you have used. Right? So if this part is clear, if question number 7 is clear, then we move on to question number 8. So kindly share Excel. Yes, surely I would. Dr. Vijay Kumar, yes, I would. Right. So let us go to question number 8. Okay. So find the distribution of women by education level in Meghalay. Okay, so finally, I've left Assam, moved to Meghalay. So I have, for your convenience, I've given the state code here as 17. You can also find this out under the value section of our variable view. Okay, so as you can see here, there are 2 select cases here. Okay, so you need the distribution of women only, not men. So gender needs to be selected. Also, you need women only from Meghalay. So you also need the state to be selected. However, education level does not need to be selected in such a case because you need the distribution. You want to see how many are not literate, how many are educated up to primary, etc., etc. So that should reflect. So there is no selection on the basis of education level because you want the distribution of that. You want to see how each level pans out. But the selection would be based on gender and state code, right? So let us go back to our data. Excuse me. So select cases. Now let me delete all of this because now we have moved to a new state. So state code 17 is Meghalay and you need women from Meghalay. So gender is 2 and we continue, right? Right. So now you need there, now we have selected, you know, our data would only, whatever analysis we perform, that will only be with respect to women of Meghalay. So we need their distribution of their education level. We need to see how their education pans out. So we will put the education level variable on this side in frequencies and click on display frequency tables because you want to know how many are in each category of education level. That is why you need their individual frequencies. Okay, so we have ticked this box and clicked on OK. So as you can see, there are 24 women in our data set from Meghalaya, total of 24 women, out of which 6 are not literate, 3 are up to primary, so on and so forth. There are 3 graduates and 1 postgraduate and above, along with their percentages. So see, around 25% of the females of Meghalaya in our data set are not literate, right? So, yes. Okay. Now, let us go to, if this question is clear, it's a pretty straightforward, yes, result obtained. Excellent. So, can we move on to question number 9? So, now we will actually move on to a little bit. I'll show you 2 ways to do question number 9. Okay. So, what do we want to find out? We want to find out the average income for males as well as females in Meghalaya. Right. So, if you notice, you may want to find the result for males separately and females separately. That is the first approach I'll take. The second approach will give you the result in a single click, which will be together. So the second approach I'll come to, but first let me go with the approach we have been following till now. So we will filter on gender and we will filter on state and obtain the average income first. So we'll be using select cases first and then we'll be using a different option. So data, select cases. If, so we need Meghalaya, so state 17 is fine, gender 2, first let me find for gender 1, males. So now we have selected males from Meghalaya and now we may want to analyze descriptive average income, right? So income variable is already here. Under options, mean is ticked, so our work is done. Okay. So as you can see, there are 16 males in Meghalaya and their average income is 13,525 rupees. Okay. If you want to do the same thing for women, which our question asks us to do, then we will simply again select cases, put gender equal to 2. Okay. Okay. Now, again, we will press analyze, descriptive, income, everything is selected. Okay. So there are 24 women in Meghalaya. We have just found that out under education level also. So there are 24 women in Meghalaya and their average income is 12,341 rupees. So the average income of females is less than that of males and so on and so forth. Whatever conclusions you want to draw, whatever tests you want to do, you can do. So in such a case, what we have done is we have used, we have had to go to data, select cases, one select for males, one select for females, and then do it. But yes, only selection in Meghalaya, you're right. So, but we can do this with a single option only. How? Let us see. So before proceeding to that option, we will go to data, select cases and all cases, because now we will be taking a different approach. So let me first select all cases. Okay. Right. So let us go back to our question. This says average income you require find. Average income has got nothing to do with data selection. That is an analytical procedure. So that is left. Males and females. So you need both the results for males and females. Where? In Meghalaya. So your selection now, let us put only Meghalaya. Okay. So data, select cases. If state code 17 is Meghalaya, we have put Meghalaya, right? Continue. Okay. So we have selected only Meghalaya, but all people from Meghalaya. Now, if you compute average income, that will give you the average income of all the 24 plus 16, 40 people of Meghalaya. It will not give you male, female wise. What do you have to do to obtain that? Male, female wise, gender wise? Go to data, split file. Okay. So there is another option right above select cases, which is split file. It is an extremely, extremely useful option when you want your output for all levels of your data in a single click. As you can see, split file option by default analyzes all cases and does not create groups, right? So if you are to, in our case, we need our output by groups, right? We need our output by gender, females and males. So we will select organize output by groups. You can also select the compare groups option. They will give you the same result. Only difference will be under compare groups, you will get the result in a single table. Under organize output by groups, you will get in 2 separate tables, but again with the single click. So let us first first go to compare groups, and we want it by gender. So I'll push my gender variable here because you want the groups based on gender. Okay. So now we'll click OK. Right. Now we will try and compute the, we will try and compute the average income. Okay. Can you see we have got our result in a single table now? We did not have to code selection twice in order to arrive at the result. You have got the same result with a single click using the split file option, right? Yes. So I hope this part is clear. You will also get the same result if you organize output by groups instead of comparing groups. See, I have clicked on organize output by groups and then descriptives of income. The only difference here is with a single click, you'll get 2 separate tables. But if you compare groups, you will get it within a single table. Okay. Okay. If this part is clear, I think we'll move on to the next question. Okay. 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 So question number 10, find the distribution of employed people by gender, social groups and marital status in Meghalay. Right. So whenever you need to find and you need to include all genders or all social groups or all kinds of marital status in your results, you know, then we will not use data selection, because if you use data selection, you know, for each social group, you'll have to, you know, state code 17, social group 1, state code 17, social group 2, so on and so forth. You will have to write each time and then get results. We will always use split file in such a case, wherein you require data for all levels of your categorical variables. Okay. So let us see how this works. So let me try by gender in Meghalay. So my only data selection case would be Meghalay. Okay. Okay. So I have selected all the people from Meghalay. Now, what do I want? I want to know how many male by gender. So how many males and females are employed in Meghalay? For doing that, I will split file by gender. I'll press compare groups and I'll, you know, the groups would be based on gender, and I will analyze frequencies with frequency tables of employment status. Okay. So, okay. As you can see, there are, you know, 16 males and 24 females in Meghalay, out of which, you know, around 50% males are employed, 50% unemployed, 95% females are unemployed, 4% employed in Meghalay. So this will give me the frequency distribution according to the genders. Now, if I want to see by different social groups, in such a case, we will split file according to different social groups. So I'll bring my social group variable on this side. I'll press OK. Again, analyze descriptive frequencies of employment we require. So, okay. So as you can see, this is the total distribution. So out of 33 people belonging to scheduled tribes, 82% are unemployed, 18% are employed. OBC, there is only one person and that person is employed. In general caste, there are 6 people, out of which 66% are unemployed and 33% are employed. Right? So you can do this according to marital status, according to different other categories as well. Okay? If you want to obtain for different districts, you can split file by districts, etc. Yes. Cross tabulation definitely will be doing this, but this is just a case of split file that I have shown you, because we do not always, we sometimes want the plain statistics, right, instead of some analytical part. So this is a better way to arrive at those plain statistics towards the beginning of your thesis or towards the beginning of your research, wherein you're giving, plain percentages and so. Yes, Neha, I can definitely repeat this. So let us do it by marital status now. Yes. So if we want to know, suppose our question is, we want to know in Meghalay, how many people who are married are working? How many people who are divorced are working? How many people who are unmarried are working or not? In such a case, what will you do? In such a case, we will select first data from Meghalay. So my data state code 17 is selected, right? Okay. Next, we will split file. Split file, what it does is, it makes groups in your file. So presently, if I want to know by marital status, I will do it according to the grouping according to marital status. I'll push the marital status on this side, right? Okay. Now, if I want to see how many people are employed according to their marital status, I will go to analyze, descriptive statistics, frequencies, and their employment status, right? Because our Meghalaya part is done under select cases, marital status part is done under split file. Here, our results will come out according to their employment status. So, okay. Right. So as you can see, out of 24 unmarried people in Meghalaya, 92% are unemployed, 22 are unemployed and 2 are employed. However, out of a total of 14 people in Meghalaya who are currently married, 7 are unemployed and 7 are employed, right? So they have more responsibility. They, a greater percentage of them work. Out of the 2 people who are widowed in Meghalaya, both of them are unemployed. They are still not into employment. Okay, so this is by marital status. So what you want to group on depends upon you. Okay, and the necessity of your data. Okay. So Ms. Jayalakshmi and Ms. Neha, I hope I have been able to clarify the doubt. Because now we will be moving on to, as somebody asked, crosstabs. Right? So this part is clear, I hope. So I have dealt with 2 kinds of things here. The first is select cases. You can use quantitative variables, scale variables or categorical variables or whatever there. Acha, one thing I want to point out. See, what happens if you have string variables? Here though we have given 17, 18 in case of, all the numeric variables. Acha, ho gaya kaam, chalo. What happens in case of string? See, our industry code is string. So industry codes tell me the industry in which a particular person is employed, right? So here industry codes are given for employed people as A, B, C, P, Q, G, whatever. Okay. So say from my data, first I'll deselect all the cases. Say from my data, I want only to analyze the people who are working in industry A. What do? You have to remember, industry code here is a string variable taking values A, B, C, D, etc. Right? So in such a case, we will go to data, select cases if, what did I just say? That we want to analyze people or data pertaining to only people who are working under industry A. So industry code equal to, if you write A, you will not get any answer because it is a string variable. So whenever in SPSS you're working with strings, you need to remember that you need to put this within quotes. So A within quotes. Continue and OK. So now what will happen is, see, in your data, case number 5 pertaining to industry A is selected, right? And the rest are not selected. See, similarly, case number 24. So if you do not put the quotes when you are selecting a string variable, you will not get the desired output. Okay? So now if you want to see the number of people, what will we do? Frequencies and say employment status, will let it be there. I'm sorry, the split file is not off. See, this is what happens. So you need to always switch off your split file by analyze all cases. Otherwise, you know, whatever analysis you do, it will give you by marital status now. So I keep making this mistake. So yes. So you see, there are 23 people in our data who are working in industry A. Okay. So this is the only point of, yes, incorrect data shows in SPSS. Ms. Jayalakshmi, have you tried with quotes? Within quotes, within inverted commas, I think then it will work, because in our case, industry code has been coded as a string variable. So whenever you're selecting a string variable, you need to put that within quotes. Okay, so now let us proceed to something called crosstabs. I will do one thing. I will simply cancel the output file because it will unnecessarily occupy space otherwise. And what I'll do is I'll put my split file off. I have checked, it is off, thank God. And now I'll put my select cases off. Okay. So before you start any new analysis, now we are moving on to the crosstabs section. I've switched off the data selection. I've switched off the select cases, right? Okay. So now, right. There is an option for cross tabulation, which all of you were doing in your previous session as well. So I think I'll just get into it straight away. So if you want to check employment status by gender, as someone very correctly pointed out, we can definitely do that by using cross tabulation. Now let us see how. As the name itself suggests, first let's go to analyze, descriptive, under descriptive statistics, crosstabs. So as the name itself suggests, it gives you a tabulation, it gives you an output in a tabular format, one variable pitted against the other. Now, usually it sort of does not actually matter which variable you put in which in a row or column, wherever it is you're putting it, does not matter ideally. But sometimes, and it is better to do it in this way, it is known as Dr. Ick rule. Okay, so it's a very simple kind of thing. I'll just, so it is DRIC. So what does this mean? So this means DR, you put your dependent variable or what appears in your research as a dependent variable into the row, and IC, so independent, into the column. So it is known as Dr. Ick rule. Okay, just, so to make it easier to remember. So in our case, we may very well say, we are plotting gender against employment status. So what are we trying to see? We are trying to see whether employment status differs as per gender or not. I'll come to the chi-square test on that, but a little later. First, I'll elaborate on the cross tabulation. So in our case, what do we usually see? Fewer females. If you look at the labor force participation rates in India throughout the past 50, 60 years, you will see that it's very low for women and it's pretty decent for men. I mean, so relative to men, women's employment situation is not very good, right? So in such a case, you would think that gender is your independent variable and employment status is your dependent variable. So what we are trying to hypothesize is whether employment status depends on gender or not. So according to the Dr. Ick rule, so your dependent variable goes in the row. So dependent in our case is, okay, so dependent in our case is employment status, right? So we'll put it in the row. So DR, dependent in the row, independent, which we are assuming gender, in the column. And you may as well display clustered bar chart. We'll see what it does. Statistics, for now, let us omit chi-square. We'll go to that a little later. If you go under cells, observed counts will definitely be displayed because that is what your table will tell you. How many are there present in your data? Let us click on expected also. And let us click on row and column percentages also. So usually these are the things that you'll be using in your research when you use Crosstabs. Okay. So I've clicked on this. Continue. Okay. So let us see how this pans out. Okay. Now, as you can see, the first is your case processing summary. So this will give you the summary of all the cases present in your data. As you can see, there are 391 cases in our data, right? So, and there are no missing values, thankfully. So we can proceed with this. Now, if you refer to this cross tabulation, you can see there are 110 unemployed males and there are 145 unemployed females, right? Similarly, there are 110 employed males and there are only 27 employed females. Okay, right? And under total, you can see total there are 219 males and 172 females in your data, which make up your 391 people. So out of these 391, 254 are unemployed, 137 are employed. Okay. So from these counts itself, you can see how heavily skewed the employment situation is in favor of males, because you see under employed section, only 27 are employed in case of females or 110 in case of males. So whenever you try to perform a test, that may come out significant. So you can get an idea from this kind of cross tabulation. Now let us look at our bar chart. What the bar chart does is, as usual, it gives you a visual idea as to how things are panning out for us. So the green bars refer to females, as you see, very high number of unemployed females and very low number of employed ones. So from here also you can sort of make an idea that maybe employment status, will differ by gender. Okay, we'll come to that. I'll go to the chi-square test, but 2 more points before that. Under cross tabulation, why did I click on the percentages? Because it sometimes helps us in our research when we, in the initial part of our thesis or in the initial parts where we are quoting numbers and percentages, you can easily see from here that, see, percentage within employment status. So, within your employment status, how many males are there and how many females are there? So, under the total number of people who are unemployed, 42.9% are males and 57.1% are females. So If you take the total number of unemployed as 100%, out of that 100%, a lion's share is females. So your unemployed pie consists of a huge chunk of female proportion. Okay. Similarly, in employed, within employment status means you're referring to this employed part here. So out of the 100% that are employed, 80% are males and only 19% are females. So out of the total number of people who are employed, lion's share are males. Similarly, here also, out of the total 391 people, 56% are males and 44% are females in our data. That is what you can infer from this. Let us go to percentage within gender. That means this 49.8% reflects that within males, 49.8% are unemployed. Okay. Similarly, within females, 84.3% are unemployed. So if you take the total female percentage as 100, out of that 100%, 84% are unemployed and 15% are employed, which totally make up this 100%. Similarly, here also, out of the total number of males, 49.8% are unemployed and 50.2% are employed. Totally, they add up to 100%. And out of the 100% of the data that you have, 65% are unemployed and 35% are only employed. So this is what we can gather from this kind of a cross tabulation, and it is of immense help when you're writing your research paper or your thesis, the initial parts, because all the necessary percentages, the composition within gender, the composition within employment status, everything you get in a single screen. Right. Now, we will proceed to testing if, there actually is a relationship between your gender and your employment status. That is, does being a male or female actually influence your employment status? Right. So, as you have noticed, here, gender is also a categorical variable. Employment status is also a categorical variable. Both of these take two values each, male, female, and employed and unemployed, right? So it does not matter how many levels each variable takes. You're always free to use the chi-square test whenever you have categorical data, either nominal or ordinal data. Okay. So now what do you hypothesize in chi-square test? Okay. Why is it known as the test for independence, test for association? Now, both of these define chi-square test. It only depends on the way you're looking at it. So if you are saying that, you want to test for independence, that is your null hypothesis, because null hypothesis is always the hypothesis of no difference. So if you are saying that there is no dependence, there is independence, then that is your null hypothesis. So if you are hypothesizing that your employment status is independent of gender, then that is your null hypothesis. And then you will call chi-square test as a test of independence. Okay. Another way to look at it is your alternative hypothesis. Your alternative hypothesis would be what? That your employment status depends on your gender, right? So how else can you formulate the alternative in this case? That your employment status has some association with the gender that you belong to. So in such a case, your chi-square test would be referred to as test of association. So, it's just a nomenclature. If you are writing your research paper as, testing your null hypothesis, you will refer to it as the chi-square test of independence. If you are referring to it as, the alternative hypothesis that there is association between this and this, then you will write it as chi-square test of association.
I'm extremely sorry. There has been a power disruption at our end because storm coming here. Yes, I know I was not audible. I had become disconnected because of there's a power. Yes, there's actually heavy rain impending here. That is right. Okay. So let me proceed again. So we had what I was trying to explain is when you refer to it as chi-square test of independence and chi-square test of association. Let me share my screen. Yes. So just give me 1 minute of time. So we were on. So if you want to check whether just a second. Yes, if you want to check whether there is any relationship existing between gender as well as your employment status, we will now use the chi-square test because both of these are categorical variables, right? As I told you, the Dr. rule will follow that. So dependent variable goes into the row, independent variable goes into the column, statistics. Oh, my voice is breaking. Right, let me try and reconnect on my other connection. Just natural vagaries are all beyond us, right? So I'm trying to join from my other connection. Please.
It's okay, ma'am. Like you can continue.
Okay, okay. So we will go to, I have already worked on the statistics. We will select chi-square because we want to check whether there is an association or not. Okay, regarding these values, I'll come later. So we'll continue. Under cells, we always need expected. I will tell you why a little later. For now, I'm skipping the percentages. So, okay. So now, as you can see, ours is the 2x2 table, right? Our table, the cross tabulation that we have is a 2x2 table because both gender and employment status are two different levels, right? In such a case, you're free to look at Pearson Chi Square, of course, you know, the value of this Pearson Chi Square statistic. However, Fisher's exact test does it more exactly, you know, as the name itself suggests. So we will be looking at the two-sided significance. Why? Because we are, you know, not going in a particular direction for males or females. We are simply saying that our alternative hypothesis is that employment status depends upon your gender. So we have not specified which gender is more, which gender is less. So we are not going for the one-sided test. We are going for the two-sided test, keeping both open. So we will look at the Fisher's test value, which is 0.000. This is our p-value. Since this value is less than 0.01 or 0.05, depending on the level of significance you want. So, you know, our results are highly significant, which gives us evidence against our null hypothesis and evidence for our alternative hypothesis, which means we can infer that there definitely is some association between gender and employment status, right? So anything less than 0.01 if you are testing at 99% level, or 0.05 if you are testing at 95% level, proves high significance, right? This value is different from the chi-square values that you get here, because this 50.467, you know, is similar to what we have done in our statistics practicals. You know, we have checked the tables, chi-square tables, calculated value greater than tabulated value, then you reject your hypothesis, so on and so forth. So this is for those kind of calculations. However, when you are using a software, we do not want to be looking at tables, right? we want our lives to be easier. I mean, that is the whole point of using a software. So what we will do is we'll directly look at the p-value. Here it is 0, which is less than 0.01, highly significant, reject null hypothesis, evidence to accept the alternative, that there is definitely some kind of a association. Okay. Right. What is one-sided and two-sided? Yes. Look, one-sided and two-sided tests are actually, that will come under the hypothesis testing portion of your course, I suppose. So I'll just be very brief regarding that. So when you are not specifying something in a direction that is two-sided, say suppose not only chi-square, suppose you're testing for average income. So suppose you're using a t-test. So you're saying that the average income is not 50 rupees. So you are not saying it is greater than 50. You are not saying it is less than 50 in your alternative hypothesis. Okay. So your null hypothesis is your average income is 50 rupees. Your alternative hypothesis is your average income is not 50 rupees. In that case, you will use two-sided test because you have not specified any direction in your alternative hypothesis. However, if your null hypothesis is that your average income is 50 rupees and your alternative hypothesis is your average income is greater than 50 rupees, in such a case, you will use the one-sided test because you specified a particular direction, right, of your alternative. Yes, one tail, two tail. Yes, this is a two-tailed one. Yes, absolutely. So, yeah, right. Okay, so chi-square does not allow us to move in one direction for more than 2 by 2 in any case. So I hope this part is clear. One thing you need to remember, in case of 2 by 2 cases only, your Fisher's exact test results will be displayed and you can use that in your analysis. Otherwise, we'll always look at Pearson chi-square values. Okay, let us try and do an example on that. So let us try and do a cross tabulation between education level and employment status, right? So as you can see from our data, let us go to our data, our education level, how many levels? 7. So you'll no longer get a Fisher's test for this, exact result for this. You will have to rely on your Pearson square result for this, right? So education level by employment status. So of course, you are expected to be better employed the higher educated you are, right? So that is the basis of our hypothesis. When you formulate a hypothesis, there's a reason behind that. So yes, exactly. It is a positively skewed test, yes, but no. This is I think yeah. I mean, at the end maybe we can address. Yes. So let me not go into that because in any case we'll be looking at Pearson and Fisher. Yeah, Pearson is not an exact test. Fisher test is an exact test. That is the difference, right? So Fisher's test will give you exact values for a 2 by 2 case only. If your case is not 2 by 2, you always need to look at your Pearson test. Okay. So in 2 by 2 case also you can look at Pearson test, just that it is not an exact test. But 99.99% of the time they'll give you converging results. Okay. So Fisher test is a very special test only, which is valid in SPSS only for a 2 by 2 contingency table. Higher levels it will not come. The results will not show. Let us see that. Okay. So in the next case, let us try and see if there is any relationship between education level and employment status, right? So what is our dependent variable here? It is employment status again, right? So let us run the test in that manner. So let us go to analyze, descriptive, crosstabs, student row doctor. So I put it here, employment status, it's cool, no issues. Now let's go to education level in our columns because we are trying to see if there is any association between education level and employment status, right? So we have clicked on chi-square, right? And we'll click on continue. cells observed expected. Fine. There's a reason why I'm selecting expected. Okay, and then let me click OK. So this is our result. You have got 391 people, 0 cases missing, so on and so forth. Right? So this will tell you that how many people are there, you know, how many postgraduates are unemployed. So there is one postgraduate who is unemployed. There are 4 postgraduates who are employed. There are, you know, 45 people who have studied up to middle school who are employed, 53 such people who are unemployed, so on and so forth. Right. There is one thing that you must check when you're running chi-square in SPSS. That is why we are doing this second example. See, when you are doing chi-square, please notice your Fisher's exact test value is not there, right? As I already told you, Fisher's exact test provides values in SPSS only for a 2x2 table. So even though our employment status has only 2 levels, our education level has 7 levels. That is why that result automatically will not be displayed to you, putting to rest all speculation. So all your conclusions will be based on the Pearson chi-square values. But you can look at this and infer it is highly significant. So, you know, there definitely is some association between your education level that you attain and your employment status. But we should not jump to that conclusion too quickly. Why? Because just look at what is written below the table. It says 2 cells have expected count less than 5. Okay. The minimum expected count is 1.75. So we are not entering into what is the minimum expected count. What we should do is, wherever we see that there are frequencies less than 5, we will either omit that group or pull that group. Okay. So in our case, if you look at, and in such a case, you cannot draw correct inference from this table. We will need to recode our data. In our case, if you look at the column postgraduate and above under your cross tabulation table, you will see that the frequencies here are expected values are less than 5. So expected count is 3.2 in unemployed, 1.8 in employed case. So what is an expected count? You know, observed count is so fine, what your data shows, you know. So your data shows that there is 1 postgraduate who's unemployed, 4 postgraduates who are employed. Expected count is your predicted number under the null hypothesis of independence. So assuming that employment status and education level are not related to each other, what would you expect the number to be? So that is 3.2 here and 1.8 here, both of which are less than 5. And that is reflected here. 2 cells have expected count less than 5. Under such a situation, what we rarely do is we omit that variable. We can omit postgraduate and proceed with our analysis. But we generally don't do that because the more data you have, the better, right? So what you can do is, if you club it with graduate level, see, then you will get an expected count more than 5. So as I told you earlier, recode into different variables as education level, as education 1. I'm doing this because it was done in my previous system. I've changed my system out page. So I am doing it again. So if my value was 6 graduate, I've kept it as 6. If it was 7, then also I've kept it as 6. And all the other values I've copied. Okay. And variable, right, of education 1. Why am I doing this? Because my count is less. So your expected count can never be less than 5. You have to remember that. Okay. So here I will simply remove number 7 and remove 6. I'll put it as graduate and above. Okay. Cancel. So this is change. Okay. Let me change this to 0. Now let's see. Yes. Just a second. Let me. Yes. Now we will analyze descriptive, cross tabulation, and we will remove this because now we have a new variable, education 1. So our statistics are chi-square, cells, observed, expected. We need expected because we need to check whether it is less than 5 anywhere. If it is less, it may so be necessary that you have to update more cells. That may also happen. So now let us look at our results. Now you see 0 cells have count less than 5. Okay, so now you can interpret these results with some amount of peace of mind. Okay, so we will look at Pearson Chi Square. Our GF is 5, of course, because it is m-1 into n-1. So for employment, it is 2 minus 1, which is 1, into education. Now there are 6 categories, 6 minus 1, 5. So DF is 5. This is your tabulated value, calculated value of chi-square, which you want. You can check with the tables also, and then it makes difference. But we don't do that in essence. We simply look at your two-sided experience, which is 0. Right. So this p-value means it is highly, highly, highly significant, and you can definitely say that there is some association between your employment status and your education level. So education seems to be having some impact on whether you are employed or you are not employed. Now we can easily do this for males and females also. So if you want to check whether for males there is any association or not, you will go to select cases, select gender equal to 1, and then perform chi-square test, and then make your inference regarding males. Or you can also use split file, group cases by gender, your results separately for males and females, so that you can make your inferences from your chi-square test for males as well as females. Okay, right. So yes, so one thing that we can also address, I think we have got in a couple of minutes, I'll just try and address this, which is your measures of association. So from chi-square test, all we have come to know is whether there is any association or not, right? However, you can check the extent of your association, how much association is there using some certain measures. So again, go to analyze descriptives, and then analyze descriptives and crosstabs and statistics. Therein you can see that you've got correlations also. Correlations are not relevant to the data that I'm using because I'm trying to analyze the relationship, if any relationship exists between categorical variables. You will use correlation only if you are concerned with quantitative variables, not qualitative ones or attributes. So we'll skip this. So this chi-square is only telling whether there is association or not. How much association is there would be told by all of these. Though we rarely use all of these, we'll use a couple of these only. Just, you can use the contingency coefficient maybe, or lambda maybe in certain cases. So usually lambda is used in cases where you have got nominal, binomial data. So in my case, we have got, say, nominal by ordinal data because, education level can be graded. So that is ordinal. So let us try and see what happens to the contingency coefficient. Okay. See, contingency coefficient, if you click, it is 0.293. Now, it shows you how much association is there. So there is generally no rule which will tell you, acha, if it is this much, then it will be strong or weak, but there are general rules of thumb. So 0.29, which is 0.3 approximately, it shows some sort of a moderate association between employment status and your employment status and your education level. Okay, so similarly, we can use lambda, same inference. So if you are using nominal variables, then you will get values between 0 to 1 for all this lambda and all, because there is no direction in such data. Only ordinal variables would have a particular direction, right? So contingency coefficient also will lie between 0 and 1, 0 indicating weakest possible association, 1 indicating highest possible levels of association. So someone has asked, what do you do if you have scale variables? If you have scale variables, then you will definitely go for correlation analysis, which also can be found here. There is correlation, bivariate, partial, etc. Or correlation in our case also. So under Crosstabs also there is that correlation thing. So yeah, it's up to you from where you choose. Scale data for correlation, but for association or independence test, which is essentially a chi-square test, which basically deals with historical data, we will use the measures as discussed. Okay. So here also you have got this phi and Kramer's V, lambda, uncertainty coefficients, all similar interpretations. Okay. But remember, these are for nominal cases. For ordinal cases where there is some order or gradation in your data, gamma is the most widely used. Okay, because tau has some disadvantage, number of rows and number of columns have to be same for tau. Tau C can be used for unequal cases also, but gamma is a universal measure using ordinal variables, and lambda or Kramer's V are mostly used, or contingency coefficient, they are mostly used if you are having nominal by nominal data, so on and so forth. So Crosstabs not only allows you to do basic frequency analysis, not only does it allow you to quote different percentages under different groups, it also allows you to perform chi-square test to test whether there is any association, and if there is any association, how strong that association is can be, done simply by clicking on any of the measures. It will give you the result, 0 indicating weakest possible association and 1 indicating strongest possible association. One pressure point to remember here, have to be greater than 5 in all cells. If they are not greater than 5, as I've told you, you need to pool your cells. So Dr. Chaudhary, I guess, yeah, we have sort of somehow rushed to the finishing line. So, yes.
You can continue if something is left, like you can give 2-3 minutes.
No, I've broadly spoken on everything that I wanted to speak on.
Yes,
So.
if any queries there from the participant side, I have unmuted them, they can ask directly.
Yes.
Few verbal questions.
Yes, I've tried to answer as possible within the session
Good
itself. Yes, from the chat.
Good afternoon, ma'am.
Yes. Good afternoon.
This is Tapas from Assam University. Ma'am,
Yes,
can we
yes.
use Yates correction for the chi-square test in SPSS?
Actually, under the option for chi-square, you do not have an option for selecting Yates correction, right? So I think it's, yeah, whatever results are displayed, we try to make do with that portion only. Right. So, yeah.
Any more queries?
So Pearson Chi Square, it's visible.
Any more queries? Maybe we explained it very beautifully.
Somebody has asked.
Like it was covered very nicely. Even the entire presentation was very structured. I found it.
Thank you so much. Somebody has asked for my contact details, so I'm just giving my phone number here. This is my phone number and my email ID if you want to reach me for any SPSS. Email is yes. So oh, sorry, it is not Guwahati, it is Guwahati. See, my typing has got across. So gauhati.ac. Yes, Dr. Chaudhary, sorry to have interrupted.
Like
So
I explained that it was so structured. You put several examples for explaining all the points, like one by one. Like it was a very nice explanation, I'd say, because even starting from selection of data to all the steps, doing all these sums and calculations, the finding out of association of these independence and chi-square test, you all explained very nicely with several examples. It was very like different sort of presentation.
I want to thank you very much for your kind words, Dr. Chaudhary. Thank you. Thank you.
So if there is no more questions, I can quickly ask Dr. Zen Lobo to provide the vote of thanks, madam. Dr. Zen Lobo.
Yes, sir. I will go ahead.
Yeah, please.
All good things come to an end, and so has this very enriching session. I thank Ms. Paramita Roy, Assistant Professor in the Department of Statistics at Guwahati University, for a very useful session on data selection, cross-tabulation, and tests of association and independence. She shared with us an exercise file to enable parallel hands-on training, starting by quickly briefing through the coding of data. She demonstrated how the coded view and the expanded form of the collected data can be made available by just a click of a button. She then moved on to explain the data selection in case we need to restrict our study to a specific area. The selection criteria have been exhaustively described. Although we are in pandemic times, I am sure that none of us felt at a distance thanks to the exercises that were completely demonstrated. The exercise session not only ensured that the hands-on session, but also gave us a complete statistical understanding of using various commands to analyze various questions that we may face while doing our research. An insight to the chi-square test that was given so beautifully explained the conditions in which we can use the test, because many a times in research, most researchers do not know which test to use when. And knowing the test, they do not know how to structure their questionnaire so as to be able to effectively use those tests. Also, points to be careful about, specifically the care to be taken if a particular frequency falls below 5 was given. A lot of illustration has made the session even more interesting. And I'm sure that we all would have hoped to hear more of this. I'm sure that all the participants have taken a lot from the session. I personally enjoyed the clarity of the explanation and the usefulness that we will all see in our research. On behalf of the AICTE, Assam University, Silchar, Assam, I once again thank Professor Paramita Roy for sparing her valuable time to teach each one of us these practical tools in such a wonderful manner. Thank you once again.
I thank Mr. Lobo for your very, 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 very kind words. I enjoy SPSS, so I just went on and on and on about it. So I want to thank the participants for your patient hearing, for your the interactive session we had, and I want to convey my heartfelt thanks to Dr. Chaudhary for having invited me to deliver a session on a topic which I absolutely love doing. So thank you very much. Thank you.
Also,
thank you for being so kind.
In future also, I think I'll find you in this.
If you are kind enough, I surely shall be glad to.
Okay. Thank you, madam. Thank you. So
thank you, Dr. Chaudhary.
I also thank Dr. Zen Lobo for his wonderful vote of thanks.
Yes.
Most welcome, sir.
So here comes to the end of this session and end of the day also. So we'll meet you again, everyone, tomorrow for the day 2. Thank you, everybody. So we are calling it a day.
Thank you. Goodbye.